So a super fast way to design a solar system is the software Helioscope. You can actually get a free trial of it just by signing up and agree to the terms, and then you get access to that software for free. Later on it will cost something. We, for example, already have that software and we're actively using it. So if you want to create a new design, you could enter the project name, which we would call commercial project, and the address, which is the address that the building is at. In our case, this would be in Germany, and we're talking about this building, and then make it a default commercial project and enter a description. Now we're creating the new project and we're arriving here and we're clicking on new and confirm to create a new design. And simple as that, we are in the designer. Now, best thing is to zoom in on the building where we want to install those solar panels and start creating a field segment. You just click on the point where you want to start and then measure the distance and go around the roof, outlining it like that. If you want to have right angles, you can do that too, but in our case we're just using the drawing. Double click on the last point and it automatically generates the layout of the solar panels. Now, to align those solar panels to your building, you can right click on the point of the layout here and set the azimuth to the automatic number that is suggested by the software. You can also adjust the azimuth here, make it 200. That doesn't look good, so we're going back and we use the automatic function. Now, this is a 2D version, but in fact we can make it in 3D. We know that the building has a height of 8 meters, and we can press Shift and drag the mouse so we can actually see the 3D view. Now, if we are adjusting the tilt to 30 degrees, you can see how the solar panels are changing. Firstly, we are actually choosing the solar panels that we really want. In this case, it's going to be a Canadian Solar 415 watt panel, and we recenter the view. This way we have a better overview. And one tool that comes in very handy is the time of the day tool, which basically allows us to automatically adjust the row spacing. So we're clicking save, and as you can see, it has automatically adjusted according to the time of the day analysis. Now, the setback of the solar panels refers to how far away they are from the edges. 1.2 meters seems to be pretty good. So here we have the field segment of all the solar panels according to the roof's measurements and dimensions. But as we can see, if we're hiding the array, there are actually obstacles on the roof, such as an AC or that dome here. So to take that into account, we are creating something that is called keepouts. It's very similar to the field segment. We're just outlining those areas and then double clicking or clicking on the last point where we began. Now, again here, we can adjust the height We'll make it 0.5 meter because this is the height of the object, and we can actually see that it has generated a corresponding shadow. And we're zooming in a bit more to also create a keep out space for the AC. And also here we can see that it has generated a shadow. Now we're showing the array again, and we can see that the panels that were too close to the shadows have now been adjusted. Now there might still be some panels that seem to be too close to the AC or to that obstacle, so we just right click on them in the keep outs field. We right click on them and they disappear. Now if, for example, we want to eliminate a whole field of panel because this is in an area where we don't want to install, we just create another keep out for that area and those panels will disappear. Another handy tool is if we want to create a path to walk between those panels, we just create a line. This line doesn't need a height. So that would be the space where we want to install our solar panels. And we could, for example, here analyze the trees if we know their height. For example, that tree has a height of 8 meters. Then we enter that like that. And we have a look in the 3D view. And we can see that that tree is not going to throw a shadow, and that the obstacles are not going to throw a shadow, and that the system actually looks pretty clean. So we recenter it, and we can already go to the electrical. Now the electrical gives us the option of choosing the inverter. In our case, we want the Sunny Tri-Power 10 kilowatt, and we're going to use 4 of those. Now, those inverters are not ideally placed. We actually want them all to be on that wall, so we're just dragging them to the preferred location. Now we can here also see and do a quick shading analysis. Theoretically, we could cut off more modules depending on our shading preferences, but we're not going to do that right now. Going back to the electrical tab, and here we can have a quick look at the single line diagram, which shows us how that would look in an electrical overview, and this is a very clean way to show what we just designed. Now we can also see that it sums up the module specification and the inverter specifications and also the wire schedule. We can even add additional combiners, or we can remove them if we don't want them. Now with this we can save and exit, and we have created our design in less than 10 minutes. So this design we can potentially export as a CAD file, as a single line diagram, and we can get all the layout images. The CAD file is a file that you can use in AutoCAD, and it comes as a full 3D file, including all the distances of the modules, how you have arranged them. So that comes in very handy as well, and the single line diagram we have already seen. Now lastly, we are just going to reports, and we are simulating the design. That is very quick, and we are getting a report that tells us that we are generating 909.7 kilowatt hours per kilowatt peak. So we're clicking on it, and this is the final production report that we're going to get. Here you can potentially upload your own company logo, and you will have all the system metrics in one place and the project location. That is not all. We have the monthly production, a nice bell curve, and we have the sources of the system losses. We can see the annual production in detail, and we can see the condition set on which those calculations are based. And then we have the components and the count of the components. In the case of the strings, the meters and the solar modules. We have the wiring zones, and we have the field segments that we have created. And very importantly for the client, we have a neat design that shows in a very clean way the arrangement of our solar panels, of our solar inverters, and how we want to install them on the roof. And this is the probably fastest way that I know to create a professional solar system design that is presentable to the end client. Thank you very much for watching. I hope you enjoyed it, and see you in the next video.